if we're talking about straight line graphs, each graph has a identity, a name, that comes in the form y equal to mx plus c. Now sometimes you can manipulate this name to look a little bit different, but once you have y alone, each name, each equation, each name has a unique line. So for example, or let's not do an example, y equal to mx plus c. The m value stands for the gradient and the c value stands for the y-intercept. The gradient means how steep is the line going and in which direction. If it's positive, it's going to be going up, and the bigger that m value is, the steeper it's going to be. And then if it's negative, it's going to be coming down, and then the further away from 0, or the bigger without a negative the m value is, the steeper it's going to be. Alright, the y-intercept just means where it cuts the y-axis. So in other words, the place over here on the y-axis, where does the line cut that? And then we call the other point where it cuts the x-axis, obviously, the x-intercept, but it's not indicated by something in the standard equation. So the standard equation is sort of like a fingerprint for each line. Each equation is unique for each line. Okay, now let's talk a little bit about lines. The standard equation represents a relationship between the x and the y. Okay, so if I put this in, what happens to the x to give me y? It's like a spider graph that you would have done in primary school, where you put in a number, you do something to it, and you get another number out, and these are your x and y values for a specific coordinate. Okay, and then you choose another x value and another y value comes out, and you choose another x value and another y value comes out. So you have 3 different coordinates here. Now, when we're looking for a straight line, we actually have a bunch of different coordinates. Let's say this coordinate over here. And then we have another coordinate over here. And then there are many coordinates in between, and they get so close to each other that you can't distinguish between them. And they start making a straight line because they're touching each other and they don't, we can't differentiate between them. So there are a bunch of mini coordinates over here that fit into this relationship given here. Okay. Now, when we are sketching straight lines, one of the first methods that we learn about is called the dual-intercept method, and this only works if in the equation y equal to mx plus c, this value, the c value, is not equal to 0. So the first thing that we're going to do, we don't know what the line looks like. So the first thing we're going to do is we're going to find this value and make it and sketch it, and we're going to find this value and sketch it. Now remember, we said in the previous video that if something is on the y-axis, then x is equal to 0, the x-intercept, the x value will be equal to 0. And if something is on the x-axis, the y value will be equal to 0. That's why we're looking for these 2 different coordinates. We can find any coordinate on the line if we have its equation. But these 2, we definitely know we can find by making x equal to 0 and by making y equal to 0. So here are your steps. Your step is use the c value to find the coordinate of the y value. You can also make x equal to 0, but it's just going to take longer. You don't need to do this. You can just read it off of the graph. Remember, this is the point 0 and c. Okay? And then for the x-intercept, you make y equal to 0 and solve for x. So this is going to be a coordinate that has an x value and a 0. and then you connect the two dots. Okay, so let's do an example of this one. We're going to sketch the line y equals to negative 2x plus 4. So for the y-intercept, the y-intercept is just this value over here. That's 0 and 4, because we just said that the c value represents the y-intercept. And now let's sketch this dot on our axes, just so I can show you what I'm doing. 1, 2, 3, 4 over there. That's the point 4. And you don't actually have to be accurate. You can guess where that point is going to be. You don't have to count it and measure it. And then for the x-intercept, we make y equal to 0. So 0 equal to negative 2x plus 4. You get the negative 2 over, it becomes positive. Divide by 2 on both sides, that gives me 2. So the coordinate here, the x value is 2 and the y value is 0. And now watch what I'm doing here. I'm not going to measure this. Like, I don't know where it is. It's about halfway that distance, so I'm just putting it down there. And you have to label it. You must tell your teacher that you know this is the point 4 and the point 2. And the reason that I'm not actually labeling 2 and 0 is because if it's on the x-axis, it's very clear that you understand that the y value is equal to 0. And then you just connect your dots. Okay, so we found 2 of the infinity number of coordinates on this line. We don't know what this coordinate is, or that coordinate over there, but we found the 2 important ones and we've connected them. So how would we mark this? For a teacher, we'd mark the y value, we'd mark the x value, and we'd mark the shape. Is it going up or down? Alright, so if you sketch this a little bit differently, but you still marked it correct, it will still be marked as correct. We don't go with a ruler and measure whether you measured 4 centimeters and 2 centimeters. Alright, let's have a look at another example that works out a little bit differently, that doesn't work out as nicely, and I'm going to show you how easy it actually is. I'm going to start with the y-intercept just because that's the easier one to do. That's 0 and negative 7. That value over there. And that's going to give me negative 7 over here. And you will see I'm not measuring at all. I'm just saying it's roughly over there. Okay. And then for the x-intercept, we make y equal to 0. And we say, okay, this is equal to 5x minus 7. I'm going to kick the 5x over. That gives me negative 5x equal to negative 7. And I'm going to divide by negative 5 on both sides. And this is going to give me x equal to 7 over 5. Now, a lot of people panic at this point and they go, okay, I have no idea what to do. How am I going to sketch this? 7 over 5 is the x value and 0 is the y value. Alright, so this is roughly, let's try and remember, this is 1 2/5. And you can also use your calculator to convert it into a decimal. So this is just after 1. Now if you were measuring this, you could use that to your advantage. But negative 7 is over there, and then I'm just going to say, okay, it's 1 and a little bit. There it is. Okay, you'll see I didn't make a big fuss about it. This is just 7 over 5. If it doesn't measure exactly, it's not the end of the world. And you connect the dots. And then if you do have more than one line on a set of axes, you must label them so that it's easy to distinguish between them. In the next video, we're going to discuss rise over run.